Okay, here we've got a functions question, and whilst we won't have seen a lot of questions like this in the textbook, they're quite common in the exam paper. And what you need to understand is that we can create a number machine with so I could have g of x is equal to 2x plus 1, which literally would mean is take your input, okay, which goes in here, and W input and add 1. Okay, so this is a number machine defined by algebra. But this question is completely different. This question is, well, your number machine, your input-output device, is created by a graph. And essentially, your the inputs, okay, go on the x-axis. So you input x coordinates, and outputs arrive on your y-axis. Okay, so for example, if I was to put 2 as an input, okay, into this graph is defining an input-output device, a number machine. If I was to put 2 in here, okay, my output would be going up to 2, and I'd go along here, run along, and I think that would be about 6. Okay, so my output would be 6. Okay, but in this question, they want me to input 3. Okay, so 3 is here, so here's 3 on the inputs. I'll go along to there and I read off. Scale's pretty kind, and so 10 dot squares, so I'll make that 2. So my answer is, if you input 3, your output on the y-axis is 2. Okay, so answer the first one is 2. Okay, the next one, okay, is different. Notice that the number is not in the input area. Okay, the input area is between the brackets, okay, and that's not where the input area is. In fact, it's at the output, isn't it? So it's saying, okay, what input gives you an output of 6? Okay, so what I'm going to do is go to the output, which are your y coordinates, run along to 6, okay, and I think actually we figured that out earlier, because I go along here, here's an output of 6, and that must have come from an input of 2. Okay, so my answer for that one is 2. The next one. Okay, so here we have a composite function, and this is a lazy way of writing this. Okay, the classic error is to go from left to right. That actually is not going to make a difference in this particular question, but it's a good idea to get into good habits. And so what we're doing is that we're working from the inside out. So the first thing I'm going to do is I'm going to work out what is the output when you put 1 in there, okay? And then I'm going to put that inside here. So if I put 1 into my number machine, what do I get? Go along here, across here, and I make that 1, 2, 3, 4. I make that 4. Okay, so that means I get a 4 here. Then I need to put 4 back in. Okay, so I'm going to go over to 4, and 4 is here as an input, and I go down here and I read across, and just be careful. Now you should use a ruler, but just for the sake of speed I'm using freehand, and I make that minus 13. So my answer would be minus 13. Sorry, just so you can see that. So my answer is minus 13. So what I did was I put 1, okay, into the number machine, which is defined not by algebra but by a graph. So I put 1 in here, okay, and outputted 4. And so if you put 1 in the F machine, you get 4. And then that, okay, is inside another number machine, F, okay, and if I put 4F on the input axis, the x-axis, 4, and then the output is a y coordinate minus 13, and that's why I've got minus 13 there.